The first thing you got to do is get a Linux server set up in the cloud. You could use any cloud provider, by the way, but I usually use Google because they give you a lot of free service. Google's number 3, so they give you a lot amount of free service to try to get people to do it. So all you do is make a free account with a Gmail account. You might have to use your personal Gmail account. Some companies block the feature. And then you give them a credit card, but they won't charge you. They give you $200 or $300 of free service. And then you can create a cloud Linux machine. And I've got one going here. Here we go. All right. You'll end up with a cloud console, and you can make a Linux machine. And I use Debian 12. It doesn't really matter what version you have. And you can just get an SSH window by clicking on that. And I've got one running here. So I'll just open another. Let's see if it's still open somewhere. There we go. Retry. All right. That's why this is really, really handy. You don't even need to have an SSH client or anything. You can open SSH in your browser, and you get command line Linux here. And now you can install things. And so the first thing you need to do is make a web server up there. So let me just go through a summary of the first couple projects here. So here you get your server running, and then you install some web server software on it to make it a PHP server, which is just a few commands. And then you can start making vulnerable pages and fixing them, which is what we're going to do here. So you would go through a few commands here to install Apache and PHP, and then someplace down here there's going to be a flag, PHP info, just to show you got that working. And then we have a series of projects where you make a vulnerable page and you fix it, and then we have some scanning we'll do. So, and then, by the way, I'll mention, because you might want to skip part of this and skip ahead to the part of greatest interest to you. So here's the overall view. There's manual testing where you make simple pages with common flaws, and then you fix them. And then you don't really need to bother with this Windows server. We're not going to bother use it much. Then you do static testing, where you analyze source code for the OWASP Juke soft, which is a famous demonstration of an insecure web app. And you can scan it with various scanners. The best one I found was SNCC, but there are others here that people like. And then you can do dynamic testing with OWASP Zap, which just got bought by Acunetics. It's the only open source dynamic scanner I know that works pretty well. So you can scan, you make a cloud version of this OWASP Juke stop and scan it. And then for C developers, you might want to go right down here to Rust, because as you probably know, C and C++ and all that are being deprecated by a lot of people, including like Microsoft and Linux community. They're rewriting the parts of the kernel in Rust because Rust is much, much safer. And I have some projects just to demonstrate the basics of why Rust is safer. And why Rust, surveys for the last several years have all said like 90% of developers say the language they would most like to write in is Rust, because it is so much easier. Because if you make a mistake in Rust, it gives you an error message and you fix it. C just does the wrong thing and you go to production and then there's a nightmare. All the common things that C does wrong, like integer overflow, string overflow, don't happen in Rust. Rust will give you an error message saying, no, you just tried to make a variable larger than 255 when it's an 8-bit variable. Stop, which is a whole lot handier than having it just get the wrong number and go to production. And then I also put in here Sodium. If you want to add encryption to any app, like all those mobile apps, you should just use Sodium. That's why it exists. The cryptographers of the world noticed nobody can understand the right key length, the salt, the algorithm. We'll just make a library that automatically chooses the best encryption and just deploys it without bothering you with the details. And that's Sodium. And it's been ported to every language. And developers should just be told, use Sodium. Do not think. Do not try to invent something. Just use the library that will automatically choose the key length and everything. And their stuff will be encrypted in a reasonable way. So I have a couple of projects you can practice that. So that's an overview of the stuff. And I'll demonstrate this stuff. But you might want to zip ahead to the topic of greatest interest to you. All right, I'm going to stop this one.